Hi, welcome. My name is Nguyen. Today I'll be presenting on the employee analysis prediction model for attrition and salary for DDSAnalytics. Here's my agenda for today. First, I'm going to talk about is the predictors, what variables give you the best prediction for attrition that are important. Next thing we're going to do is once we found those important predictor variables, we're going to put into a model prediction using either K&N, naive Bayes, or linear regression. Then from there, we're going to find the model that gives us the best accuracy, best sensitivity, and best specificity that matches at least 60%. Once we're done with that, we're going to go ahead and model salary, but we're going to go ahead and use linear regression for the last part of modeling salary using the same data set of predictor variables. So here's a quick summary of attrition. If you look at the attrition count here on the right, you see that there are more no responses than yes responses, approximately 730 no's compared to only 140 yeses, which makes about 19% of the full data for yeses. So that's about 1 out of 5 employees will leave DDSAnalytics. That's very alarming. Why is 20% of the company? Is that a normal percentage of those who leave the company? And so we want to study that more and find out the factors that tend to give out more attrition. So first thing we're going to do here is just taking the first logical approach, which is what factors are related to income, wages, and money. So I went ahead and took approach of these 5 variables, which is daily rate, hourly rate, job level, monthly income, and lastly, monthly rate. We see here that daily rate, hourly rate, monthly rate have approximately normal means. So they're all about the same, with the same amount of standard deviation. The two that appear different are monthly income. Okay, because look at the box plot for that, their means are completely different. Even those the standard deviations are different. That also includes job level too. Look at the mean levels for job levels. This is clearly different from this one with different standard deviations. We went ahead and went more analysis of that. So you can clearly see here for monthly income, 71% of people who have no's have higher incomes than people who have yeses. So there's that number itself has a high percentage on predicting power, as well as job level. Over 40% of those who are at level 1 tend to quit more than those who are at level 1 for attrition for no's. And so there definitely has to be some sort of job level relationship between that and attrition. So what I did was I went ahead and compared monthly income to job level on the scatter plot here, and you can clearly see that there's a linear relationship. As you go up in job level, you also go up in monthly income, which makes sense because if you're at a lower job level, you tend to get paid less. Okay, and if you get paid less and at a lower job level, there is a connection to yes attrition. So it makes sense that monthly income job level does play some sort of cause for attrition. And we want to, in our analysis, we want to see some interaction between the two. So moving forward, we're going to pick monthly income and job level as a strong predictor of our data set for attrition. Let's go ahead and detail for monthly income. For monthly income, we took a look at the histogram. You can clearly see here at the people with the lower monthly income have the exact same percentages of those who have no's. So monthly income does play a role in attrition. Those who have more lower income have higher attrition rates. So look, 47 average income of attrition yes is about 4,700. Average income of attrition no's are about 6,700. So there is a clear difference between yeses and no's. We went ahead and did a Welch's 2-sample t-test to test if there's a significant difference in the means, which we found that yes, the mean difference is not 0. Went ahead also took a look at job level. If you look here at job level, over 25% of those who have attrition yeses have the job level 1, and whereas the other 2, 3, and 4 are roughly about the same, where 4 is the lowest attrition rate. So that makes sense. The higher you are in your job level, the least likely you're going to be in terms of quitting. But if you're at the lower job level, you're more likely to quit. And we performed just 2 sample t-tests as well on this, and we found that the mean difference is not 0. So I went ahead and did a data analysis for the other factors that we thought were important. That gave us the most significant values, which were job role. If you look here at job role, sales representative have higher attrition rates, whereas those who have director roles did not have higher attrition rates. So you can clearly see that those who have certain job roles, such as those who work in the sales department, tend to quit more than those who work in the more supervisor roles, such as being directors, which makes sense. Now, the next logical kind of like explanatory variable is job satisfaction and relationship satisfaction. But you can clearly see in both of these graphs, they do not have some sort of statistical significance in their means. They're all pretty much around the same amount. So we'll go ahead and overlook that. But now let's look at marital status. Marital status has a increasing attrition rate if you start with divorce, married, and single. But we can clearly see that single makes the most sense because those are the individual with the most amount of those at the single level tend to quit more because they're more easy. They can travel more. They have more freedom to travel between doing different things, more ambitious, more goals in life. Whereas divorce and married, they tend to stay rooted, not to quit their job, but stay at a single job. So that makes sense. However, out of all the other factors I looked at overtime as my last strong top predictor because if you clearly see here, there are only 2 sets of variables, not no different degrees of roles and categories. There's only 2. It's either you worked overtime or you didn't work overtime. So no's and yes. We clearly look at if you did work overtime, you're more likely, even almost double, near triple, the amount of attrition rates if you worked overtime. So overtime seems like a factor where if you work overtime, you're more likely going to quit. So we went ahead and add that to our strong predictors as well. So our top 3 is monthly income, job level, and overtime. Next thing we're going to do is we're going to go ahead and model the attrition using our set of predictor variables. Okay. So first thing in our step 1 is we're going to clean up the data. We're going to go ahead and check for NAs, which we didn't. We're going to create dummy variables out of categorical variables and scale the data set using 70-30 split. After that, we're going to go ahead and pick our models. We're going to use which model we're going to use is naive Bayes, K&N, or linear regression. What we did was that we found naive Bayes to be the best model. After we use naive Bayes, we're going to use all the initial variables that were given to us to predict attrition. And after we ran that model, we'll see which ones give us the best statistically significant values. And then from there, we're just going to keep those statistically significant variables and run it through the naive Bayes model again. And that will give us the best model that we can have for naive Bayes using forward selection kind of style. All right, so here's our final model comparison. So naive Bayes, K&N, and linear regression. Naive Bayes came out as the winner just because it has the best accuracy, the best sensitivity, or not the best sensitivity, the second to best sensitivity, but it matches the specificity of at least 60%, which is at 84%. K&N we could not use because specificity was at 20%. It needed to be at 60% for us to use this. And so we're going to go ahead and use naive Bayes. Linear regression, we could not use linear regression because of how the model or attrition is set. Attrition is a binary variable, so it's either 0 or 1. Linear regression is better for numerical responses where it can give you a number. So without having to use logistical regression, we went ahead and just not use linear regression. Our model and just picked naive Bayes. So with naive Bayes, here's our best predictor variables. We found that job level, monthly income, and overtime, which we predicted in our initial analysis, are part of the model, but we had other ones as well, such as monthly rate, number of companies worked, performance rating, years with current manager, relationship satisfaction, years at company, years since last promotion, and BT rare, business travel rare. So all these makes sense with staying or leaving out of the company, just because if you're, for example, performance rating, if you tend to have lower performance rating, you tend to quit. Higher, you're going to stay at your job. Same with years since last promotion. So again, best model, best accuracy, best sensitivity, best specificity for my model. Lastly, I'm going to go ahead and talk about is modeling the salary. Same thing I did for modeling attrition. I went ahead and cleaned up the data, set all the categorical variables to dem variables, and split this data set into the train 70 and 30. All right, now picking the model, we're going to have to choose the best statistical analysis of exponential variables that give you the best statistics. So went ahead and performed a initial linear regression using all predictors and interactions. So what I did first was, again, I used all the predictors and interactions as my step 3. This could be step 3 and 4, and step 5, I went ahead and chose those with the significant values at 0.05 using a forest selection model. So let me give you the full detailed picture of this. So phase 1, I ran the multiple linear regression on all the predictors. I found the statistically significant values. In phase 2, those significant values were job level, job role, total working years, business travel, gender, daily rate, monthly rate, years of income, years last promotion, distance from home, performance rating, salary hike, and department. I took those variables and went on phase 3 when I ran an interaction against each other. This analysis gave me an RSME of 970 and adjusted R-square of 0.9554, which gave us the best model. We ran different models, but this one gave us the best one for our regression equation. So this is a regression equation with all the interactions with those variables. Now, here's our conclusion, prediction of attrition and prediction of salary. So with attrition, our top 3 predictors are monthly income, job level, and overtime. And our best model to predict is naive Bayes, which with these accuracy, sensitivity, and specificity. And on our prediction of salary, the top 3 predictors are job role, job level, and total working years. The best model for that, using what we did with interactions, gave us an RSME of 970.6 and adjusted R-square of 0.994. So again, these are our top models, and you can find the RShiny app on myshinyapps.io/BoShiny2 to see a in-depth analysis of this. Thank you so much. Have a great rest of your day.